सर पीपीटी शेयर नहीं हो रही। सर शेयर के ऑप्शन में सर कर रहा हूँ, लेकिन सर शेयर
तो पहले थोड़ा सा करके चलना चाहिए ना, तो मैं किसी के साथ में मॉक आज इस चीज़ों से बच्चे भी वाकिफ़ हैं कि कैसे प्रेजेंट करना, तो प्रेजेंट करने में भी 10 मिनट लग रहे हैं।
शेयर स्क्रीन से हो रहा है कि नहीं हो रहा है?
सर प्रेजेंट के ऑप्शन में क्लिक कर रहा हूँ तो सर शेयर योर एंटायर स्क्रीन, इसके बाद सर शेयर के ऑप्शन में क्लिक नहीं हो रहा है।
अतुल जी,
जी जी very good morning sir, ma'am. I am Arun Raj. I am presenting a presentation on fractal antenna under the guidance of Dr. D. Karia sir and Dr. D.K. Srivastava sir. The objective of my presentation is to study on different fractal antenna with an overview of recent developments. And here is the outline overview of my presentation: introduction, methodology, simulation, comparison, conclusion, applications, merits, demerits, and references. The first introduction: the fractal antenna plays a most important role in the field of wireless communication due to its multi-band and wideband characteristics. This is the reason that the use of microwave fractal antenna has been a recent topic for the researchers in the world. The fractal means the irregular fragment with a set of complex geometry that produces the self-symmetry structures. Fractal antenna concept was given by Vincent Cohen in 1995. The self-similarity and
इंट्रोडक्शन को आगे बढ़ा के आगे आगे बताओ और थोड़ा सा माइक पास में करो।
जी सर, fractal antennas used for different applications and frequency band of interest. It is used for multiple frequency bands. The expected benefit of using a fractal as a dipole antenna is to minimize the total height of the antenna at resonance, and the geometry of fractal is important because the effective length of antenna increases. The methodology: design, simulation using software, fabrication and testing, comparison of simulated measured results. Software. Here software requirement: IE3D software, HFSS and CST software. So IE3D software is used in my work. IE3D in design system. When I open IE3D software, the first window is that file and IE3D SSD, and then mgrid and
स्लाइड शो कर लीजिए फुल स्क्रीन मोड पे।
when I go IE3D software, I file and IE3D SSD and then go mgrid and mentor graphics. Then this type of window is open and I start create new, and then I decide dimensions and the frequency range, and a patch antenna, rectangular patch antenna I took, and I cut slot E-plane for my iteration first. And line feeding is here in my slot E-plane antenna. After the simulation setup and the different frequency point, and I find S parameter graph and the VSWR Smith chart graph. Here the S parameter graph, S parameter,
ये अरुण काय से निकाले हैं ये सारे ग्राफ वगैरह?
ये सर जो सर ई प्लेन सर डिजाइन किया है सर, इसी का रिजल्ट है सर।
ये डिजाइन तुम्हारे खुद के रिजल्ट है सिमुलेशन के?
यस सर।
किए हैं सारे रिजल्ट?
यस सर।
और सबको दिखा दिए थे?
नहीं, मेरे को व्हाट्सएप भेजे थे इसने कर लिए, मैं दोनों करेक्शन भी करवाए थे ट्रांसपेरेंसी पे।
अच्छा, मतलब आपकी जानकारी में है ना सर ये सिमुलेशन?
हाँ, वो परसों इसने भेजे थे, कहाँ से लिए, मैंने क्या किया, पहले जो किए हैं वो बनाओ, है ना, फिर करेक्शन भी करवाए 2 दिन से।
हाँ, मतलब ये है कि जितने भी स्टूडेंट है ना सर, सभी सुपरवाइजर को कम से कम काम दिखाते ना कि हो क्या रहा है सर।
2-3 बार से भेजे थे, पर फिर कल भी बात हुई थी, मैंने करेक्शन करवाए ट्रांसपेरेंसी में भी, कुछ ऐसे ही डाल दिए थे जो मतलब उसके है, मैंने नहीं जो अपने काम बताओ, और अब जब आएंगे तब तो हार्डवेयर बना के रिजल्ट आएगा, वो एक्चुअली होगा, है ना।
जी जी जी,
हाँ, जब आ जाएंगे हार्डवेयर बनाएंगे, जब रिजल्ट आएगा तभी कुछ होगा प्रॉपर। तो
क्या
So, sir, this is different frequency point. I get result in minus 1.8 here. And here is the equation 2. This is the square array patch antenna. Here I am also doing line feeding, and this is simulation, and S parameter graph is here नीचे आ रहा है सर। This is sir iteration 3, and here I work for fractal, different fractal here, and this S parameter graph is minus 10. Here I am comparing the VSWR Smith chart and S parameter and gain of all iteration. Different frequency point I got gain, directivity, maximum conjugate match gain, voltage source gain, so pattern calculation. I get gain minus 6.7711 dB, directivity minus 0.080773 dB for each plane. And this is the Smith chart for each plane. Basically, this Smith chart used to display actual antenna impedance. But this is the VSWR. VSWR describes the power reflected from antenna. This is for iteration to square patch array antenna, gain minus 13.484 dB, directivity minus 0.549094 dB, and Smith chart for square patch array antenna. This is VSWR chart for square patch antenna. This is for iteration 3, fractal array antenna, gain minus 6.35 dB, directivity 6.2261 dB. There is comparison of 3D pattern of all 3 iterations. Iteration first we get this gain, total gain of 3D pattern of D plane. This is for square patch array antenna. This is for fractal array patch. The concept of the, sir, here I am conclusion. The concept of fractals can be applied to design of antenna elements array. publication about the electromagnetic theory of fractal structure and various fractal elements and array are readily available. That the most fractal have infinite complexity and detail makes it possible to use fractal to design small size, low profile and low weight fractals.
एक तो अरुण तुम थोड़ा सा माइक पास में रखो, दूसरी ये बताओ आपका पूरा प्लान क्या है इसको वर्कआउट करने का?
सर फ्रैक्टल एंटीना यूज करते हैं हम, जिससे कि सर एक तो एंटीना का साइज कम हो जाता है और इफेक्टिव लेंथ बढ़ जाती है।
नहीं,
और
ये सब तो आपका सही है। साइज बढ़ गई, लेंथ साइज छोटी हो गई, लेंथ बढ़ गई।
सर एंटीना की साइज कम हो जाती है और
काय में कम हो जाती साइज? किस में कम होती मतलब
जो
किस
सर
पर? लेंथ कम हो जाती, ब्रेड कम हो जाती, एरिया कम हो जाता, क्या कम हो जाता? साइज मतलब क्या है?
साइज मतलब सर स्मॉल साइज डिजाइन, मतलब जो एंटीना बनाने के बाद जो एंटीना।
अरे किस प्रोस्पेक्ट में कम हो जाती साइज? लेंथ कम होती, हाइट कम होती, ब्रेड्थ कम होती, थिकनेस कम होती, क्या कम होती है?
हाइट, सर उसकी हाइट कम हो जाती है सर।
हाइट कैसे कम हो जाती है? हाइट कैसे कम हो जाती? हाइट कैसे कम हो जाती? तुम्हारा शेप क्या है? जरा शेप दिखाना अपने एंटीना का जो तुमने सिमुलेशन में यूज किया होगा।
ये है सर।
श्रीवास्तव जी, डीके श्रीवास्तव जी,
देखिए सर चलेगा। चलो इसका रिटर्न लॉस कितना आया था?
आ गए सर, डीके सर आ गए।
क्यों रिटर्न लॉस कितना आया था इसका? रिटर्न लॉस कितना आया? रिटर्न लॉस कितना आया था इसका? रिटर्न लॉस कितना आया था?
सर रिटर्न लॉस इसका -10 dB से कम है।
-10 dB पे थोड़ी ना होगा, 20 के आसपास आना चाहिए। और थोड़ा सा बेसिक चीजें, जो बेसिक क्वेश्चन पूछे जा रहे हैं, बिल्कुल ही तुम ये पढ़ लो जरा बेसिक, ऐसे काम नहीं चलेगा है। साइज कम होगा क्या, लेंथ कम हो जाए, बिट कम हो, क्या कम होगा, क्या होगा, क्या क्यों करते फ्रैक्टल, क्या है उसके रीजन, ये बेसिक चीजें तो पढ़नी पड़ेगी ना तुम्हें। क्या ही 3D पे बैठे एक दिन में कर दिया, ऐसे नहीं होता ना। बेसिक फंडामेंटल थोड़े से ठीक से पढ़ो जरा ढंग से, क्या होता, कौन सी चीज क्या होती। भैया पूछे डीके श्रीवास्तव जी आपके लिए। हेलो
डीके सर,
हाँ सर,
अनम्यूट होइए।
बताइए बोलिए।
हाँ सर, आप पारी करिए।
अच्छा इनसे।
हाँ
हाँ सर।
हाँ अरुण।
जी सर।
हाँ तो ये और रेडिएशन पैटर्न निकाला तुमने, स्मिथ चार्ट या रेडिएशन पैटर्न?
जी सर।
अरे यार रेडिएशन पैटर्न तो बहुत जरूरी है, उसको निकालो। जैसा सर ने अभी कहा कि इससे पहले तो कॉन्सेप्ट
निकाला हुआ है।
नहीं, ये तो तुम्हारा 3 डायमेंशनल है कि 2 डायमेंशनल है?
ये सर 3 डायमेंशनल है।
तो 3 डायमेंशनल से कौन सी एनालिसिस कर पाओगे? 2 डायमेंशनल निकालो और उसकी एनालिसिस करो। कौन कौन से होते हैं रेडिएशन पैटर्न? बताओ थोड़ा रेडिएशन पैटर्न।
सर 2
और ये
डायमेंशनल एंड 3 डायमेंशनल।
है
2 डायमेंशनल एंड 3 डायमेंशनल।
नहीं, रेडिएशन पैटर्न से क्या मतलब समझते हो, क्या है?
सर रेडिएशन पैटर्न सर टोटल गेन शो करता है। सर टोटल गेन शो करता है।
ई प्लेन एच प्लेन क्या होता है? इसमें चार्ट का आइडिया है?
सर इसमें चार्ट सर एक्चुअल एंटीना इम्पीडेंस।
ये सारे कॉन्सेप्ट्स क्लियर करो, है ना। 3D पे तो आपने बना लिया, ठीक है, और लेकिन ये कॉन्सेप्ट तो क्लियर होना चाहिए कि क्या कर रहे हो एक्चुअली में, ठीक है।
और अरुण, तुम्हारा क्या है पूरा प्लान? प्रोजेक्ट कंप्लीट कैसे होगा? अभी जैसे सर ने भी अपने कुछ इनपुट्स दिए हैं, डीके श्रीवास्तव सर ने, दुकारिया सर ने, इन सारे जो भी सजेशंस हैं इनको इनकॉर्पोरेट करो। और प्लान क्या है, कैसे जमा करोगे अभी आगे, प्रोजेक्ट कंप्लीट कैसे करोगे?
सर ये सर मैं फ्रैक्टल में आगे सर काम करके
अभी आगे क्या करोगे, अगला प्लान बताओ क्या है?
सर अभी सर डिफरेंट डिफरेंट फ्रैक्टल डिजाइन करके सर इसका गेन और
और
सर जिसका गेन आए मतलब अच्छा रिजल्ट आएगा सर उसको
अच्छा
मतलब
रिजल्ट किस किस एस्पेक्ट में अच्छा आएगा ये बताओ ना।
जैसे कि सर जो मैंने फ्रैक्टल डिजाइन किया है इसका सर गेन -10 GB से आ रहा है, तो सर इसको 20 dB तक या
माइनस
20
ट्वेंटी dB तक?
-20 dB या और इससे मतलब अच्छा रिजल्ट आएगा सर उसको आगे।
अभी सब हवा हवाई बात मत करो तुम लोग, है ना। आप पूरा एक
जी
प्लान
सर।
बनाओ, पूरा एक फ्लो चार्ट बनाओ, कैसे कैसे काम करोगे, क्या क्या तुम्हें निकालना है। और पूरा निकाल के अपने सुपरवाइजर को भी दिखाओ, और एक प्रेजेंटेशन जल्दी होगा, जल्दी डेट डिसाइड करके एक प्रेजेंटेशन करेंगे। आप लोग अपना पूरा प्लान बताइए, किस तरह से आप काम करोगे, कैसे इसको एक पूरा कंप्लीशन करोगे प्रोजेक्ट को। पूरा आपके पास प्लान बिल्कुल क्लियर होना चाहिए, और क्या क्या इसमें एनालाइज करोगे।
जी सर।
सर और कोई लोगों के क्वेश्चन हैं? सर आप लोग पूछ लीजिए। अतुल जी, अतुल जी आप उसको कराइए। इनके बीच में कोई नहीं है क्यों अतुल जी? रोल नंबर वाइज यही है? शुरू करिए।
यस सर।
और नेक्स्ट कौन है वो और बता दीजिएगा, जिसमें वो भी तैयार रहे। अतुल जी नेक्स्ट भी
सर
बता दीजिएगा, जिससे वो भी तैयार रहे, अदरवाइज।
सर स्क्रीन शेयर नहीं हुआ।
Yes, sir, present too.
यस सर स्क्रीन शेयर नहीं हो रहा है सर। सर सर शेयर के ऑप्शन पर क्लिक ही नहीं हो रहा है। Good morning, respected HOD sir, faculty members, and my dear batchmates. My name is Harshali Barman. Today I am presenting a presentation, and my presentation topic is Artificial Intelligence in the Design of Microstrip Antenna under guidance of Dr. Shahnaz Ayub ma'am. Yes, sir. Dr. Shahnaz Ayub ma'am, Associate Professor, Department of Electronics and Communication. Sir, slide is visible? So these are the outlines of my project: introduction, methodology,
नहीं आ
design
रहा है
of
कुछ भी स्क्रीन के
स्लाइड
ऊपर।
नहीं दिख रही,
the screen.
नेट का इश्यू है तो बीच में अटक गया है।
Yes, sir. Sir, visible? So slide is visible? No. तो स्लाइड सर विजिबल हो रहा है स्लाइड अभी? फिर मैंने प्रेजेंट
नहीं हो रहा अभी, मेरे को भी नहीं है, पता नहीं।
सर मैं फोन से कर लेती हूँ ज्वाइन। सर मैंने शेयर किया। यस सर। ओके प्लीज आउट।
प्रेजेंटेशन का जब ऑप्शन आता है ना, उसमें तुमको टैब या विंडो में वो विंडो सेलेक्ट करनी है जिसपे तुम्हारा प्रेजेंटेशन ओपन है। उसमें 3 ऑप्शन आएंगे, प्रेजेंटिंग ए टैब, प्रेजेंटिंग ए विंडो। तो विंडो पे करोगे तो फिर वो पर्टिकुलर जो प्रेजेंटेशन है उस पर क्लिक करना पड़ेगा। ये तुमने इसी को प्रेजेंट कर दिया है।
सर मैंने
इसको
प्रेजेंटेशन ही ओपन किया है सर। यस सर मुझे दिख रहा है आउटलाइंस। ओके सर।
मैंने अपनी स्क्रीन शेयर कर दिया बस।
इतना टाइम लगेगा मतलब एक के बीच दोबारा तो बहुत टाइम हो जाएगा।
तो सर मैं
इसको एक बार मॉक नहीं कर लेना चाहिए था तुम लोगों को? सब लोग मिलके मॉक कर लेते। तुमको जब ये प्रेजेंट करना है, स्क्रीन करने के बाद में ऊपर से दूसरा सेलेक्ट करना है। तुमने योर स्क्रीन कर दी ना, वो नहीं काम करेगा। प्रेजेंट योर स्क्रीन नहीं करनी है। प्रेजेंट योर एंटायर स्क्रीन के नीचे आता है विंडो और टैब। तो टैब या विंडो में सेलेक्ट करना है, योर एंटायर स्क्रीन नहीं करना है। सुन रही हो ना? प्रेजेंट में दूसरा ऑप्शन आएगा, वो करना है। अरे इसमें तुम्हारी पर्सनल चीजें हैं, ये पूरा मोबाइल इसमें ओपन मत करो। इसको अभी ऑफ हो, एंटायर स्क्रीन हटाओ। प्रेजेंट और एंटायर स्क्रीन हटाओ। अरे ये तुम्हारा मोबाइल स्क्रीन पूरा शेयर हो रहा है, इसको मत करो, इसको बंद करो। कोई सेंसिटिव इंफॉर्मेशन इसमें आ सकती है। तुम इसमें करो प्रेजेंट नाउ। प्रेजेंट नाउ में ऊपर से दूसरा नंबर आएगा विंडो, वो विंडो वाला सेलेक्ट करो और फिर उसको प्रेजेंटेशन पे ले जाओ। प्रेजेंटेशन पे ओपन करके रखो विंडो में। पहले प्रेजेंटेशन ओपन करो साइड में, फिर जब प्रेजेंट पे जाओगे, प्रेजेंट ऑप्शन पे, तो ऊपर से दूसरा नंबर आएगा अ विंडो या अ टैब। इन दो में करना है, और एंटायर स्क्रीन नहीं करना। फिर तुमने अपना योर एंटायर स्क्रीन शेयर कर दिया है ना? एंटायर स्क्रीन शेयर नहीं करना भाई। अरे भैया तुम्हें तो इसी पे आधा तुम्हारा प्रेजेंटेशन तो आज इसी पे ही हो गया कि कैसे स्क्रीन शेयर करी जाती है। अब इनको किसी दिन और बुलाओ फिर।
उसको हटाइए, हर्षाली को ना थोड़ी देर में देखते हैं बाद में। आज हमारे ख्याल से आज कंप्लीट करा तो ज्यादा अच्छा रहेगा। अगले हाँ 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 ठीक ठीक, उसको इन्फॉर्म कर देना। हमारे ख्याल से एग्जिट की ना वो अभी देखने के लिए, फिर बता देना इनको। कल्पना को अपने प्रेजेंटेशन के बाद उसको बता देना, बाद में होगा।
ओके ओके सर। गुड मॉर्निंग
इसमें है ना स्लाइड शो करो, स्लाइड शो ऑप्शन आएगा, F5 प्रेस कर दो। हाँ ये कर दो।
सर। इज इट विजिबल?
हाँ ये स्लाइड शो ऑप्शन क्लिक करो फ्रॉम बिगनिंग।
सर इट इज स्टार्टेड फ्रॉम बिगिनिंग ओनली सर।
नहीं नहीं उसको क्लिक करो तो ये साइड की चीजें हट जाएंगी फिर।
Sir, is it okay now? Good morning, HOD sir, and all the faculty members and my dear batchmates. My name is Kalpana Sahu. Today I am going to present a topic which is name of control of reverse osmosis water desalination system, which is under the supervision of Professor Deepak Nagaria sir, head of the Department of Electronics and Electrical Department, Dr. N.S. Beniwal sir, associate professor, and Dr. S.K. Singh sir, assistant professor, EC department. Here are the some contents of the topics: abstract, introduction, literature review, block diagram of basic reverse osmosis system, variable frequency drive with.
नेक्स्ट स्लाइड पे नहीं आया, स्लाइड करो, नेक्स्ट स्लाइड पे लेके आओ उसको। अभी फर्स्ट स्लाइड
कल्पना ये जो फर्स्ट पेज आपने बनाया है ना,
Yes, sir.
करो करके हो ना जो
आपने जो फर्स्ट स्लाइड बनाया हुआ है ना,
Yes,
इसमें
sir.
आपने सबका जो नाम लिखा है उसमें सर आप वर्ड हटा दीजिए वहां से, ठीक है?
Okay, okay.
आप बोलने वक्त बोलते हैं बट यहाँ पे लिखने की जरूरत नहीं है, प्रोफेसर दीपक नगरिया सर लिखने की जरूरत नहीं है कहीं पर भी, ठीक है?
अच्छा
Okay, sir.
हाँ,
Okay.
you can
प्रतिभा में-
write name. Yes.
लगा रखा है।
हाँ, सर आप
लिखने
उससे
की
हटा दीजिए।
और पीपी के अंदर F5 दबाइए, जो सर कह रहे हैं ना, F5 दबाइएगा, F5 से वो बड़ी हो जाएगी स्क्रीन। जो भी कर रहे हैं वहां
Sir,
पर
वो-
F5 दबाइए, या फिर उसमें जाके ना पूरा बिगिनिंग करिएगा।
सर एक सेकंड।
ये जो तुम कर
Okay,
रही हो
sir.
ना, विंडो का साइन है उसके नीचे फ्रॉम बिगनिंग लिखा हुआ है।
नहीं
फ्रॉम बिगनिंग विंडो के साइन के जस्ट नीचे।
सर एक सेकेंड।
उधर
हाँ ये
और
सर इज इट विजिबल ना?
नहीं है, उसको उधर बिगिनिंग पे जाके ना पे जाके आप करो, उसको क्लिक करो।
नहीं तो आप एक काम करिए, जो राइट साइड बॉटम पे आ जाइए कल्पना, राइट साइड बॉटम पे आ जाओ आप, जहाँ पे 75% लिखा हुआ है ना, राइट साइड बॉटम पे आ जाओ अपने स्क्रीन पे, 75% लिखा हुआ है जहाँ पे, उसके लेफ्ट साइड में जो कप का सिंबल बना है ना, वहां पे आप क्लिक कर दो।
चलो इसमें समझ तो आ ही रहा है। चलो इसमें समझ तो आ ही रहा है। सेकंड कंटेंट वाली स्लाइड फिर से दिखाओ।
एक सेकेंड सर।
इसको स्क्रॉल करके लेके जाओ पीछे, नंबर 2 स्लाइड।
Sir, is it visible?
हाँ ठीक है।
Okay, so here are some content which is abstract introduction, literature review, block diagram of basic reverse osmosis system, fuel frequency drive with motor and motivation problem statement object references. Here in abstract, this work focuses on the design and simulation of PI controller system, a PI control system for RO reverse osmosis membrane water desalination system to address the changes in the feed water supply and the ratio in other system parameters. Basically, this control system is implemented on a reverse osmosis system using MATLAB simulation. In the introduction part, water desalination refers to the process of the removal of salt and other minerals from water to make it suitable for human consumption. So this technique is uses for the RO membrane for water desalination, which is basically a semi-permeable membrane. In a normal osmosis, the solvent automatically moves from an area of low solute concentration to an area of high solute concentration through a membrane. So while the RO is then opposite technique in which the solvent moves from an area of high solute concentration to an area of low solute concentration through the membrane. So to perform this task, the technique requires an externally applied force to overcome the osmotic pressure. So as we see in the RO is only the capable of RO is capable of removing many types of molecules, ions, and bacteria from water. So in water desalination plant, feed water is the wastewater is to be desalinated. In this process, a high pressure motor is used to maintain the externally applied pressure. So the retentive outlet is provided with an actuated well whose positions can be controlled. This is the part of literature review, sir. In the industrial RO desalination process, mainly use a proportional integral P and PI controller to control the production flow rate and to control feed pumps. Basically, these controllers are able to maintain a constant product flow rate, but are unable to give an optimum performance of the plant with respect to the set point transitions has been studied, and it has been found that due to the non-linearities plant present, the plant tends to deviate from the optimal response. In the model-based control, it is a good alternative to deal with such problems. So the model-based method like model predictive control and the base control have been simulated for water desalination by computers. Here comes a block diagram of basic reverse osmosis system. In the block diagram of basic reverse osmosis system, this, as we see, it's working in the above in this block diagram. Their all basic elements has been shown above here, which is of a traditional RO water desalination plant. The feed water enters the high pressure pump, which is equipped with a variable frequency drive. So this pump pressurizes the feed water to feed pressure. The pressurized stream then enters the membrane module. The reverse osmosis membrane bifurcates the feed water stream into a low salinity permeate and a high salinity retentate. This is a variable frequency drive. So the variable frequency drive is also known as adjustable frequency drive. So we can adjust the frequency as we want the frequency. So it can be drive basically used in the electromechanical drive systems to control AC motor speed and torque by varying and frequency. This is the block diagram of variable frequency with the motor, sir. And the basic VFD variable frequency drive system and components that constitute the variable frequency drive systems explained in the block diagram of the system. This diagram contains many such components named as AC motor, controller, operator interface, and drive operation too. So in the AC motor, these motors generally are three-phase induction motor, which is used in a variable frequency drive system. And controllers are the VFD controllers, variable frequency drive controller, which is basically a conversion system made up of solid state power devices. And operation interface, it is used for adjusting the operating speed of the motor. And the drive operation can be categorized as single quadrant, 2 or 4 quadrant. Here are some motivations lines in the RO water salination is one of the most widely methods of water salination. So low cost, easy installation, it can be the low cost, easy installation, energy efficiency, and good product quality are the main reasons behind its wide acceptance. So the performance of these plants is traditionally being controlled by the two independent and PI controllers. Objects of this topic is to study the basic RO plant and its working, to observe the changes in the retentive flow controller output by changing the flow rate, to design the PI controller, proportional integral controller, which is capable of changing its output with respect to the percentage change in the feed flow rate or the first controller's output. And next, to implement the above controller in the MATLAB simulation and to compare the performance in both the cases. These are some differences.
तो कल भी तुमने इसमें सिमुलेशन स्टार्ट किया कि नहीं किया अभी?
सर मैंने सिमुलेशन का मतलब MATLAB इंस्टॉल कर लिया है. सिमुलेशन वर्क इज गोइंग ऑन. अभी मैं थोड़ा बेसिक पे काम कर रही हूँ सर सिमुलेशन पे.
अच्छा, सिमुलेशन टूल तो आता है, उसमें करना कैसे करना है MATLAB पे?
हाँ सर, मतलब आई एम लर्निंग, आई एम स्टिल लर्निंग, बट सर इट विल बी कंप्लीटेड ऑन टाइम सर.
ओके ओके. और तूने जो लिटरेचर रिव्यू में पेपर देखा है, ये पेपर ने पढ़े हैं सारे?
जी सर, मैंने पढ़े हैं ये सर.
ओके ओके. तो कब तक तुम इसको कर सकती हो, अपना काम कब तक कंप्लीट कर दोगे? क्योंकि कॉलेज में तो अभी आना हो नहीं पा रहा है.
सर आई विल ट्राई.
तो तुम अब लोग सुपरवाइजर से कॉन्टेक्ट भी किया करो ना कभी. अब तुम लोग एमटेक वालों के लिए थोड़ी बनाई, कभी आओ अपना काम दिखा के जाया करो. कभी स्टूडेंट्स अपना डिस्कस किया करो. बिल्कुल ही सब रुक गया है डिस्कशन तो.
ओके सर, वी विल कम टू कॉलेज. So it will be completed on time, sir, till March or.
अच्छा चलो, अभी नेक्स्ट सिमुलेशन के रिजल्ट बताना मेरे को जल्दी करके.
Okay sir, thank you sir, thank you all the teachers.
डॉक्टर अतुल जी ठीक है. और किसी को कुछ पूछना है इनसे नेक्स्ट? नहीं तो फिर अलाउ करो.
Okay sir. Okay sir, sure. Thank you sir. Okay sir, thank you sir.
Good afternoon, everyone. So, here again, good afternoon, everyone. I am Sabina, student of MTech second year in digital communication. And here I am today to present my presentation, which is guided by Dr. Mahendra Kumar and Dr. Atul Kumar Dwivedi in front of you. On the topic design and optimization, as well as the comparative analysis of the T-shaped slot loaded microstrip patch antenna using the particle swarm optimization. The contents relevant to the topic in my presentation includes the introduction, the literature reviews that is followed by the software used, and the methods are followed by antenna geometry and the design features, which are inculcating the optimization methods as well as the manual optimization methods, where I will be defining the PSO algorithm as well as the optimization applying PSO, which is followed by curve fitting, conclusion, and the references. So here I want to go with the introduction of my topic. That is, in today's scenario in the wireless communication system, there is a great requirement of the low profile and the handy antennas. So for that, as well as which is carrying the high bandwidth, the wide bandwidth and the high gain as well. So for that, I have chosen the microstrip patch antenna because it is providing all the benefits such as low profile, lightweight, and compactness. But at the same time, it comes with the various disadvantages, or we can say there are some shortcomings of the microstrip patch antennas as low efficiency, the lower gain, and the narrow bandwidth. So for that, we will be taking some of kind of the things which are included. Dielectric constant should be in the range of 2.2 to 12, as we have to select the dielectric constant as low as, because it will increase the gain of the antenna. Efficient operation will be at the resonating frequency, as we know that for making the size compact, the lambda is the beneficiary factor that have to be modulated. So resonating frequency plays a role over that. For that, we will be performing some kind of optimization to get the better results. Those are the manual as well as the particle swarm optimization. For designing and to carry out my research, I have done the various literature reviews, which are including the Chalker and Behra, who has proposed the inset feed dual band antenna, utilizing the same optimization technique, that is particle swarm optimization, with the 33.54 MHz bandwidth. Rajput et al. Has presented the fractal bandwidth of microstrip antenna, on which the loaded with the I-shaped patch, as well as the optimization technique was PSO, and it was also followed by the curve fitting. Sorry for the interruption. Kiberia et al. Has implemented the modified PSO with method utilizing IE3 for the simulation purpose and achieved the rectification in the bandwidth with 12%, and size reduction was 20.84, which is the requirement of today's video. They et al. Has done the gap coupled rectangular microstrip antenna. Optimization technique was PSO, and the resonating frequency was kept between 3 and 18 gigahertz. Thereafter, we are having the Chang et al., who has carried out his results over the asymmetrical T-shaped monopole dual band simple antenna. Substrate that was used was FO4, which was basically used by all of those as well. For the resonant frequency, the bandwidth enhancement, he has done his results out. Hu et al. Has done the planar antenna loaded with T-shape and two symmetrical edges resonators, as well as the applications he has designed for was multi-band, that is for wireless LAN and WiMAX. Thereafter, we are having Keitana et al., who has worked on two T-shaped symmetrical slot antenna loaded with multi-bed microstrip antenna, and then the resonating frequency was kept between 4.84 gigahertz and 6.81 gigahertz. Application that has been used for the ultra wideband. And then thereafter, the Goel et al. Has presented the design of inverted T-shaped antenna working in triple band, which was having its application in X-band. Ni et al. Has done his research work in a multi-band T-shaped antenna loaded with T-shaped slots, utilizing the line feed and the coplanar waveguide feed, which was having the application as well as in the same, that is wireless LAN and WiMix. Morgan et al. Has done his work in the elliptical shape patch antenna loaded with T-shaped slot. Substrate was utilized FR4 and the applications were in multi-frequency operations. Reddy et al. Has designed the circularly polarized T-shaped square patch antenna, which was having its application in WiMix, with the resonating frequency keeping between 2.5 to 9 gigahertz. Kumar et al. Has designed the band-notch T-shaped slot antenna, planar antenna with inset feed for ultra-wideband application. Verma et al. Has designed the slotted T-shaped patch antenna, and it was optimized by the manual method for the bandwidth enhancement. So from the above results, from the results of the researchers and the methodology they have obtained, I have decided that I will be utilizing 3 of the software for the work which will be carried out by me. That is how I have planned my things, that I will be utilizing the IE3D simulation tool, thereafter the Graphematica tool for curve fitting, and the MATLAB will be for the part where I will be deciding the algorithm for that in order to perform the specific optimization scheme. And for the simulation, I have been using IE3D. So for the methods, the antenna geometry is the very crucial procedure. In the very first step, in order to decide the dimensions of the patch, as I have selected the rectangular patch, here I am having the parameters in order to calculate the width, that is given by the formula in equation 1. Thereafter, the epsilon r is the dielectric constant that I have taken in my procedures is 4.4, and we will be finding the extension length in order to carry out the length of the patch, which will be reflected in this slide as well in equation 4. So hence thereafter we can calculate by putting the value of epsilon r, and after calculating the value of epsilon, reflective epsilon over here as 28.83 mm and 7.26 mm respectively. In order to carry out the various ground length and other parameters, we will be evaluating by these equations, and hence we will be getting the results of the ground length and the width of the patch. The geometry will be look like this, but we will be selecting only L1, L3, W1, W3 as shown in figure this for the optimization per and for other carried out results. So here is the comprised result that I will be using in order to design the antenna. As the epsilon, I have already told you the substrate material I will be taking at the epsilon r 4.4, and height, that is thickness, will be at 1.6 mm, and these are the different patterns of that. After, as I have worked on the software, this is the very initial script. After carrying out the results, I am deciding the substrate which is I'm using, that has been commented over here, and the dielectric constant has been fitted as 4.4, having the loss tangent of 0.02. Thereafter, I have designed this. I have carried out the various steps in order to design the microstrip patch antenna, like which is T-slotted. As I would like to show you one another, this is the 3D of the design that has been designed by me on the IE3D software. Before moving forward, I would like you to go through the very initial steps that I have presented in another PPT of mine. which is over here, where I've shown each and every step that I have followed. As you can see, these are the steps of making the coordinates in order to design the antenna. I have taken each and every screenshot while designing the antenna. This is one of the results, as I have designed many of those. So that is how we designed. Finally, we can cut the slot. Thereafter, we can just have the final antenna over here. So again, moving with the same. Here I am having my 3D dimensional of the slotted antenna. Thereafter, we will be simulating the results for the frequency parameter from 1 to 4, where the highest frequency has been kept by me as 4. As you can see, the meshing frequency in gigahertz has been set as 4 and taken the 1000 points in order to display it on the graph. Thereafter, this is the screenshot, which is showing that the simulation is being in the process. Thereafter, the results are there. The very first results, when I kept the setting of Modua over there on the software, we'll be getting the return loss graph, that is the S parameter graph as 1, 1. So we will be analyzing that where we are getting the better results of the return loss graph. That is, what is the return loss? So I was getting the return loss, which was more than 27, minus 27 over there, which is a great return loss that should be required. But my gain, not the gain, the frequency was not near to the desired design frequency. The desired design frequency was around 2.45 gigahertz, but my frequency was not near to that. So for that, I have done the iterative thing. I have designed the T-shaped slot various times in order to bring the frequency near to that. So here we are having the voltage standing wave ratio versus frequency graph, which is one of the another results, where you can see at the frequency 3.8, which I was getting the return loss, I am getting the VSWR as 1.14, which is quite near to the standard one, as the required result should be. Thereafter, I am having the 3D pattern, or the radiation pattern, we can say, of antenna, where the red color portion is defining that the radiation is over here at its max. That is, I'm getting the gain of 6.125 to 1 dB, which is almost at the requirement, because we know that microstrip patch antenna has its limits to the 7 dB. It is the two-dimensional radiation pattern of my designed antenna, one of the design, which is shown over here. So we can just go through this as well. Thereafter, I have also plotted the various graphs by utilizing IE3D, the total graph, where we know that at what frequency I'm getting the field gain at its max. Thereafter, I have also simulated it for the current distribution in E-plane. So this is the maximum E-plane current distribution, which is given by 5.19 ampere per meter, which is not as that accurate at this time, but I will be working on this iteratively in order to get the better results. So as I have told you that my frequency was not near to the desired frequency, for that we are in need of optimization methods in order to get the desired frequency, because iteratively it will become more complex and time taking. So what I will be doing, I will be optimizing my methods over using the manual optimization as well as the PSO optimization. For why this is done, as I have selected the 4 parameters of the dimension of T slot, which are L1 and W1 and L2 and W2. What are L1 and W2? What are L1 and W1 are? L1 is the width of the vertical arm of the T slot. W2 is the width of the horizontal arm, as well as L2 and W2 are dimensions of the feed line. So we will be taking only these parameters out of 10s, because These are the parameters which are responsible for the radiation of the particular antenna. So we will be varying it one by one, keeping the others as is it. So here we will be varying the
शाब्या,
parameters. Yes, sir.
शाब्या, इसमें जैसे तुमने मैनुअली कहा है और तुमने कहा है पीएसओ से, तो मैनुअली कितने इटरेशन करोगे?
Sir, manually iterations can be done on the basis of the parameters, as we know that L1
तो ये तो
parameter.
हिट एंड ट्रायल होगा ना, ये तो टोटल
Yes, sir. It
मैनुअल
can.
में.
Yes, of course, sir. But we know the range of the parameters now. Sir, L1 parameter ranges between 7 to 14. We will be having 10 plus 1 antennas over there. I will be showing you the table for that as well. We are having a kind of particular desired limit L2 parameter as well. We will be having 13 plus antennas for that, and we will be having number of antennas for that, which is increasing the 20 more than 30 antennas will be designed by keeping others constant and varying the one of the parameter within the range which is provided for the antenna. So for that we will be getting a certain number of designing, and we will be performing the results by manually over there.
And how will we formulate the objective function for the PSO?
So I have described in the further slides as well.
Okay.
We'll take.
Acha, what do you mean by this slot loaded, Sabya? What do you mean this slot T-shape slot loaded antenna? What do you mean by this slot loaded?
So by the slot loaded, which means is that, so first of all, we will be setting up the ground plane. After that, we will be just performing, we can say the micro strip patch, which will be in rectangular in shape, and will be
सभी एंटेना में डबल सेम एंटेना में सभी में ग्राउंड प्लेन होता है, एक अपर प्लेट होता है, रेडिएशन पैच होता है, बट व्हाट इज स्लॉट लोडेड? स्लॉट एंटेना इज डिफरेंट टाइप ऑफ.
Yes, slot is what I have done on the patch that you can see in the previous slide. There was T which was slotted over there. The T shape has been slotted, which was cutted out from the patch of the antenna. That is how the slotting is done.
Then which say comes out? Which say comes out? अपने एक रेक्टेंगुलर से टी कट कर दिया. This is not a slot loaded. Slot loaded means this is different. Say slot loaded is different things, right? Slot antenna is different.
Yes, a slot has been cutted over there, na? So that is why the slot has been loaded over the antenna.
Over the antenna, no?
Yes, sir, over the patch of the antenna.
सिंगल लेयर है ना, ओवरलोडेड कैसे हो सकता है? सिंगल एंटेना है ना, दो सिंगल डाइलेक्ट्रिक है, फिर स्लॉट लोडेड कैसे हो जाएगा? फिर स्लॉट लोडेड कैसे?
Sir, I have loaded another slot over there, na? So T-shape slot, as I have shown you in another PPT, each and every step was there. So what I was doing is I will loaded the slot. So I can show you on the IE3D as well. While we are designing, the another slot has been loaded.
So two dielectric is used.
No, sir,
One.
I have used the only one.
One is single dielectric, na? Single dielectric,
Yes.
na? Then
Yes, sir. Sir, I have loaded with the same dielectric over there, and thereafter I have just performed with the slot over there.
चलिए कितना, जब भी कोई प्रेजेंटेशन हो आप अपना वर्क प्रेजेंट किया जाता है, आपने जो है पूरा का पूरा रिव्यू वर्क प्रेजेंट कर रहे हैं, किया है नहीं किया, दिस इज नॉट द रेफरेंस. आपका जो प्रेजेंटेशन है व्हाट यू
Yes, sir, I can show you what.
है ना. अभी आप
Yes, sir.
अभी आप
So what I
पूरा रिव्यू या लिटरेचर
Yes,
रिव्यू
sir.
वो नहीं प्रेजेंट करना है, आपने अपना क्या करना है, वर्क किया है वो प्रेजेंट करना है. दिस इज फॉर प्रेजेंटेशन
Yes,
फॉर
of
दी
course,
योर
I am-
वर्क. नहीं
Yes,
स्वरूप
sir, I'm
आपने जो
presenting my work as well. I can show you that as well.
not
Sir, I
only
have done with each and everything.
ये i3D पे क्या है?
So I have done. Yes, sir. I have done on i3D. Everything has been done. So I have done the various iterative. Even you can see the files. I have done the various results over there as well.
चलिए जल्दी करिए, बताइए. और ये सब नहीं, अरे आप अपना वर्क प्रेजेंट करिए बस, अभी ये सब नहीं दिखाइए.
Okay, sir. I have done I have done the work over there, sir. So what I'm saying is, I will be going with the manual optimization, then the particle soil optimization utilizing the MATLAB program. Thereafter, in the manual optimization, we are having the parameters L1, L2, as I have already discussed, W1 and W2, which are having the lower bound and upper bound. For this, we will be designing the antennas, which I have done. So I have designed the various antennas over there and the number of antennas, and I will be taking out the best results out of those. As you can see, at L1 is 12, we are getting this result, which is the best out of the range of L1 from 4 to 14 with the step size of 1. So we will be getting 10 antennas for that as well. And the best results for L2 was for 2.5 mm. For the W1, it was best results was for 4 mm, and for W2, it was best results for 7 mm. So for that, we are having the best results for the bandwidth at L2, as we can see in the previous slide as well. For L2 at 2.5, we are getting 5.59 bandwidth, which was increased, and 27.44 return loss, which was also the required one. So that is why we have taken in the manual optimization method, that is the results, the final results of that, and which are compared with the conventional. So up to this point, I have compared the manual with the conventional one, where I realized the bandwidth has been enhanced, and the return loss and the WR was also enhanced, as I have showed you in the graphs, and the resonating frequency was not close to the desired frequency. As I have already told you, I have not get the results by having the resonating frequency to the desired frequency. So I am working on getting the frequency at desired, getting the results as optimized results. So due to this, as my resonating frequency is not coming to the desired, I will be utilizing PSO. As we know at every point that the manual optimization has its limitations, so the PSO will overcome those as well. For PSO algorithm, what is the process of PSO is iteratively trying to improve the candidate solution with regards to some measure of quality. PSO optimizes the problem of iterative attempting to the upgrade and candidate solution with reference to measure of quality. This is expected to move the swarm towards the solution. Therefore, PSO begins with arbitrarily selected positions and velocity of particles. The key elements of the favorable outcome of PSO particles velocity modulation is that. So we will be having carried out the same parameters. Those 4 parameters which has been selected in the manual will be carried out over here, and what we will be amplifying is the FBW of the convention T slot by keeping the frequency, that is resonating frequency, should be keeping near to the 2.45 gigahertz. So for that, I will be performing PSO in furthermost days. And then thereafter curve fitting. What is curve fitting is basically is realizing for each and every parameter with respect to the bandwidth and the resonating frequency on the graph. This is the graphical presentation of the relationship of the parameters individually. The parameters are L1, W1, L2, W2. The conclusion is that IE3D solution tool has been used by me, and I will be analyzing and obtaining the results at bandwidth and the resonating frequency, which should be near to the desired frequency, and Graphematica software will be used for the generation of the curve. I will be developing PSO algorithm in MATLAB. Enhancement of fragmentary bandwidth will be done by me for the T-shaped slot loaded antenna, and keeping the resonating frequency near to 2.45 is my aim for now. The references which I have taken are here as follows. Thank you, everyone. So before moving forward, before ending my presentation, I would like to show you some of my results. These are over here. I have done. Yes, sir.
हेलो
Yes, sir.
शाब्या, stop the presentation. सुनो,
Sure,
सभी
sir.
लोग, बाकी लोग भी सुन लो। आपको आपने क्या किया है अभी तक वो बताना है यहाँ पर। दूसरा क्या है कि आप लोग किस तरह से आप प्रोजेक्ट कंप्लीट करोगे, ये आप अपना पूरा फ्लो चार्ट बना के रखिएगा। सभी लोग, हर किसी को इंडिविजुअली नहीं, सभी लोग, कि आपका प्लान ऑफ एक्शन क्या रहेगा और किस तरह से आप कंप्लीट करोगे कि आपका हार्डवेयर, सॉफ्टवेयर और प्लस आपकी थीसिस दिया जाए। ठीक है, तो उसमें आप क्या क्या चीजें करोगे बिल्कुल क्लियर होंगे। अपने गाइड से भी आप बता दीजिएगा, गाइड के भी आप सिग्नेचर ले लीजिएगा कि आपका ऑप्शन होगा या जो आपका फ्लो चार्ट होगा फ्यूचर प्लान का वो किस तरह का होगा, वो आपको उसी को फॉलो करना है। और आपको क्लियर कट पता होना चाहिए कि 15 दिन में मैं ये कर लूंगी, 20 दिन में ये कर लेंगे। हमारी अब मार्च तक हमारी सारा वर्क कंप्लीट हो जाएगा, अप्रैल में हम थीसिस राइटिंग करेंगे, सबमिट करेंगे। पूरा प्लान इसका क्लियर होना चाहिए। ठीक है, आप अभी लोग प्लान करके जो पी को है ना प्रोफेसर डी के श्रीवास्तव जी, उनके पास आप अपने गाइड लेके सबमिट करा दीजिएगा। ठीक है, अभी आप वो अभी ले लीजिए अपने गाइडों से, और बाद में जब भी कॉलेज खुलता है, जब भी आने का होता है, आप तो प्रोफेसर के श्रीवास्तव जी के पास अपना प्लान सबमिट करा दीजिए। चलिए अतुल जी, नेक्स्ट ब्लॉन है अतुल जी। अब एक और लास्ट है ना, ये लास्ट होगा ना? नहीं, कितने? 5 है ना? 5 है तो
इसके बाद अभी तो
अच्छा,
उसका
इसका
हरसाली का बचा हुआ है ना।
हाँ, हरसाली का ही बताओ। जल्दी जब तक उसे इन्फॉर्म करा दो हरसाली को कि अपने तैयार कर ले इन लोगों के थ्रू। शाब्या, वो क्या नाम, कल्पना, उसको इन्फॉर्म कर दो।
Sure, sir.
Sure, sir.
Sir, can I start?
यस यस, स्टार्ट करिए जल्दी करिए भाई। और अपना वर्क प्रेजेंट क्या किया साक्षी?
Yes, yes, sir, yes, sir.
यस,
Is it visible to all of you? Yeah. Okay. Good morning, everybody, and welcome to my presentation. My name is Sakshi Sharma, and I am a student of MTech Digital Communication, and I am under the guidance of Dr. Suren Srivastava. The topic of my dissertation presentation is on design and development of SIW-based antenna for 5G applications. So these are the main focusing points of my presentation, which is introduction, literature review, research gap, objective of work, software used, and references. Let's start with the introduction. In this part, I will talk about substrate integrated waveguide and its excitation techniques and its purpose, pros, and its limitations. What's yes, sir? Hello.
आप अपना वर्क प्रेजेंट
सर पीपीटी शो हो रही है सर कि नहीं?
हो रही है।
ओके। Let's start with the introduction. In this part, I will talk about. Sir, your voice is not. Sir, actually, your voice is not clear, sir. Sir, is it visible? Hello?
Yes.
Yeah, okay.
Yeah,
In introduction part, I will talk about substrate integrated waveguide. A substrate integrated waveguide, which is also known as post-wall waveguide, is a synthetic rectangular electromagnetic waveguide which is formed in dielectric substrate by densely arraying metallized posts or by holes which connect the upper and lower metal plates of the substrate. The substrate integrated waveguide has emerged as an attractive alternative which incorporates non-planar waveguide structures in planar substrate by the use of rows of metallic wires implementing the sidewall of the waveguide based circuit in planar substrate. The structure as shown in figure, it consists of 3 layers, which is top and bottom ground planes and dielectric layers in between these two planes. Metallic wire array of holes is placed between these two planes as shown. SIW excitation techniques. SIW components can be manufactured with any processing technique such as printed circuit board or PCB process, low temperature co-fired ceramic LTCC techniques, and photoimageable process. The operating frequency range is delimited by the notation of quantity TE10 wave, as its cutoff frequency is only related to equivalent with AEQ of the synthesized waveguide as long as the substrate thickness or waveguide height is smaller than this width. Now the purpose of SIW. The microwave devices such as filters, antenna arrays, power dividers, directional couplers, phase shifters, couplers, transition, etc. are designed and manufactured using SIW structures due to its several benefits. Now the benefits or pros of the SIW is power handling capabilities are higher, radiation losses are lower, fabrication cost of various RF components using SIW structure is lower, high density integration can be achieved in mountation of discrete components on SIW structures. Due to use of metal conductor, loss is low. Limitations of SIW. Leakage losses are substantial, which depends on separation of wire holes placed on the top planes. Due to use of dielectric into the waveguide structure, dielectric losses will occur compared to air used in normal rectangular waveguide. Moreover, it depends on frequency and hence millimeter wave. Applications of SIW need to be carefully considered. Due to its waveguide structure, SIW exhibits cutoff frequency of lower values. Now let's move on to the next topic, which is literature review. The modern communication system require broadband antennas and or multi-frequency operation modes. These goals have been accomplished employing slotted patch for the gating element with the aim to preserve compactness and to maintain the overall layout as simple as possible. The continuous advancement in
लिटरेचर रिव्यू इसको इस करिए.
so
लिटरेचर रिव्यू नहीं बताना, आपको अपना वर्क बताना.
okay sir. As you can see, the design of my reference paper, which is bow type design on the microstrip patch antenna, and this is the figure of real and imaginary Z11 plot of cavity without and with slot loading, and the next graph is shows the comparative study between simulated and measured reflection coefficients and gain of the antenna. And in my second reference paper design is on the 5G applications.